Next in our parallelogram-a-thon, easy for me to say, we're going to look at some types of parallelograms that are so special that they get their own name. And the first one we're going to look at is called a rectangle. Now, you've been dealing with rectangles for, let's call it, a long time now. So you're pretty familiar with these. But let's look at them in terms now of using what we know about parallelograms. So a rectangle is defined as a parallelogram with one right angle, which seems kind of odd given what you already know about rectangles, that all the angles in a rectangle are right angles. But let's check this out. We have a rectangle and it has one right angle right there. Well, we also know that a rectangle is a parallelogram. So this side's parallel to this one, this side's parallel to this one, and that also tells us something about the angles. Remember that in a parallelogram, any consecutive or any group of consecutive angles is going to be supplementary. So this 90-degree angle is supplementary to this angle. So that means that if I take this 90 plus whatever this is, it has to add up to 180. Well, the only option there is 90. So we know that this angle is a 90-degree angle as well. Now the same thing works over here. These two angles are consecutive angles. They must be supplementary. So that one's a right angle as well. We also know that opposite angles are congruent, so if that one's a 90-degree angle, that has to be a 90-degree angle. So just by saying that there is one right angle in a rectangle, we say that they're all right angles. Alright, here's some other properties. Remember we said this objective was just kind of a listing of all the properties we needed to know about these shapes. So here's some of the extra special properties of rectangles. So the stuff I'm about to say here is true of just rectangles and not other parallelograms. So first, it does have all the properties of a parallelogram because it is a parallelogram. So opposite sides are still parallel, opposite sides are still congruent, opposite angles are congruent, consecutive angles are congruent, and the diagonals will still bisect each other. But now we can add to it that all angles are right angles. So if it's a rectangle, if you're told it's a rectangle, we're not assuming anything by saying that all the angles are right angles. And lastly, we can say that the diagonals of this thing are congruent. And if you'll recall, a diagonal is something that looks like this. It connects the vertices of opposite angles, so it cuts across the figure. And so if I take my two diagonals on this figure, those are congruent. So this blue line will be the same length as this red line. Now that combines in a very neat way with the property of parallelograms. All parallelograms have diagonals that bisect each other. So that means that in a rectangle, every single one of these little segments from the middle out to each of the vertices of the angles, that segment is congruent to this one, is congruent to this one, is congruent to this one, and so on and so forth. So in a rectangle, all those little pieces are going to be congruent. Alright, next up is a figure called a rhombus. And a rhombus is a parallelogram, so just like a rectangle, it's a type of parallelogram. But in a rhombus, all four sides are congruent. So that's going to look something like this. You'll have your four-sided figure, it's a parallelogram, so all the parallelogram stuff applies. And we can see that all four sides are going to be congruent. So that's the same length as that, as that, as that, so on and so forth. Alright, so let's look at some of the properties of this one. So there's a rhombus. Here's what we know. It has all the properties of a parallelogram, just like I described with rectangles. So all that stuff still applies. But in addition to that, the diagonals are perpendicular to each other. So we can draw those diagonals in, and what we know now is that in a rhombus, those are going to be perpendicular to each other. And so all the other stuff still applies too. These still bisect each other, and now they bisect each other and are perpendicular to each other. And again, all of this is in addition to our definition of all sides are equal for a rhombus as well. And we also know that in a rhombus, the diagonals will bisect opposite angles. So if I take this blue diagonal, and I look at, let's say, this angle up here, that blue diagonal is going to bisect that angle. So it cuts it into two equal parts. So this angle up here will be congruent to this angle up here, and that'll be the same down here. This angle will be congruent to that angle because it will bisect those angles. The true is also the same, or Wow, that was terrible. It's also true for this one. This diagonal is going to bisect this angle. So this angle is equal to that one, and so on and so forth. So that's a rhombus. All the sides are equal, has all the properties of a parallelogram. Diagonals are perpendicular, and the diagonals bisect opposite angles. Now notice this is a large group of facts we're developing on this. There was plenty of stuff to remember just for the parallelogram. Now we have extra things to remember for a rectangle and for a rhombus. Make sure you're studying this stuff to know it, that you will be asked to remember these properties. All right, our last figure that we're going to look at is a square. And again, this is one that you've been dealing with for many years now. But a square, in terms of how we're discussing things now, it's a parallelogram with 4 congruent sides, which also contains a right angle. So if you stop and think about that, a square is a parallelogram, but it's also a rhombus. Our definition for a rhombus was that it has 4 congruent sides, so a square is just a type of rhombus. It's a type of rhombus which contains a right angle. But hey, didn't we say that a rectangle was a parallelogram with a right angle? So a square is kind of an extra special case. A square is a type of rhombus, and it's a type of rectangle as well. And as such, it has all the properties of all this stuff that we've talked about. So a square has all the properties of a parallelogram. It has all the properties of a rectangle, all the properties of a rhombus. All of that stuff is all going to be true in a square. So the 3 figures we've discussed, we have a rectangle, which has a right angle. We have a rhombus, which has all sides congruent. And then we have a square, which is a combination of the two. It has at least one right angle, which makes all the angles right angles, and it has all sides being equal.